Using the new keyword to construct a new object from a class is known in object-oriented talk as instantiating the class. That is, you're creating an instance of the class, and that instance exists in the form of an object. There is only one way to create an object in Java, and that is to use the new keyword. Every object you encounter in a program, no matter where it seems to come from, was at some point created by using the new command. You probably remember an example similar to this form in a previous lesson. Here, the Java virtual machine loads the class file and executes the main method. At this time, there is no object. The main method, being static, has been fully realized by the compiler and has been sitting in the class file just waiting for something like this to happen. Notice, however, that inside the main method there is a new statement. This statement creates an object from the class and stores the address of the new object in a reference. The very first thing that the new statement does to create the object is to allocate memory necessary to hold it. In this block of allocated memory is a place to store the string reference named quick. The rest of the allocated memory is internal stuff for bookkeeping and the like. The only thing peculiar to this particular object is that space has been allocated for the string reference. The first thing the constructor does is create a string object and store it in the reference. Recall that every variable declared within a class but outside of any method is available to every method of the class. However, it is not available from the main method because it did not exist when the main method started executing. It only began to exist when the main method executed the new command to create the object that holds it. If the string reference named quick had been declared as static, then the main method would have been able to access it because it would have existed in the class just as the main method does. However, if the string reference were declared as static, there would only be one of them, and they would all be accessed from every object created from the class. Here is a modification of the program that shows how more than one constructor can be employed. This is basically the same program, but with two constructors, and with the code to display the window set off in a method of its own named showWindow. The first constructor is just like the one in the previous example. It stores a string in the reference named quick, and then displays the window, this time by calling a method. The second constructor accepts a string as an argument, which it stores in the reference, and then calls the method to display the window. The label object is constructed with whatever string has been stored in the string reference. Now the main method creates two objects. The first new statement creates an object by not specifying the string. This causes the first constructor to execute, storing the default string into the quick reference. The second new statement specifies a string as an argument, and that causes the second constructor to execute, and the specified string is displayed in the window. When the program is run, this is what happens. Two windows are displayed because two objects of the same class are created, but each class is its own independent agent and has its own set of data.